This is for Year 12 Specialists. It comes out of 2D. Question number 9. And I've done part A and part B. Part A asks for vectors A to B, and second part A to C, and then find the vector resolute of AB in the direction of AC. So using this rule here for vector resolutes, I've come up with that. Part B says the shortest distance from B to line AC. So if I go back, these questions are all linked. I used the answers for A when doing part B. Probably the answers for C, I'm going to use my answers from part B and A in part C. So if I've got vector AB, and then I've got A to C. In part B, I broke AB into a vector which was perpendicular to AC, which is U, where U is the defined vector in the direction of B of the first vector. And then I can break one into a perpendicular one. And I know U, this is U here. Part B says the shortest distance from B to the line AC. Well, that distance there is going to be the shortest distance because that makes a right angle. Where it makes a right angle, it means that from point B to that line, it must be the shortest distance, because any other distances that don't make right angles are going to be longer. So this question is asking find the other vector in the vector resolute, but it's asking for its distance. Okay, I know U, this is U. I know AB, so if I call this V, then V is going to equal minus U plus AB. So it's going to be minus 3 on 13 in the I, plus 15 on 13 in the J, plus AB, plus 13 on 13 in the I, minus 13 on 13 in the J, minus 26 on 13 in the K, which is going to be minus 3 plus 13 is 10 on 13I, 15 minus 13 is plus 2 on 13 in the J, and minus 26k on 13, and double checking on a calculator the magnitude of that because I want its distance. So it's going to be the square root of 10 on 13 all squared plus 2 on 13 all squared plus 26 on 13 all squared, which equals, and I'll just work it out, equals on my calculator 2 root 195 on 13, and that's going to be the distance. So part C was really asking about V, but they ask it in a different way. And part D, the area of triangle ABC. So I'm looking for the area of that triangle there. And I'm going to give myself some space. Okay, what are all of the formulas that I have for working out areas of triangles? I can use area equals a half base times height. No good in this case because while I know the base, I do know the height. So it's going to be a half. The base is the magnitude of AC, root 26, and the height's going to be that shortest distance, which is 2 root 195 over 13. The 2's cancel, which gives me on 13 the square root of 26 times 195, which is 13 root 30. The 13 stands to give root 30 square units, is going to be my area. While that gave me the answer straight away using this formula, other formulas I have for the area of a triangle is a half AB sine of C. So if you knew this angle, it would be that length, which I know is root 6, this length, which I know is root 26, and if I could use the dot product to find that angle, I could use that angle. And my third formula that I have for finding area of triangle is Heron's formula, which is the square root of S times S minus A times S minus B times S minus C, where A, B, C are the lengths of those three sides. And while I knew A and B, I didn't know C, and S is A plus B plus C divided by 2. So in this particular case, this was the formula that was the easiest one to use.